Golfing is one of the most popular outdoor sports played in America. This past month, the Masters has been taking place on television. Many people find golfing to be boring. However, when we break down the physics of golf, it becomes very interesting.
Louis Saison, king of the swingers. Louis. JB Holmes is as ball as there. Is it going to get round it somehow or other? Oh, no! No! Go on! Go on! Oh, that's unbelievable! Goodness!
To start off, let's find the speed of the club during impact. We know to find the velocity, we have to do change in distance over change in time. So first I'll mark 2 points, one random point and 1 point during impact. Finally, this can be tricky because there is a curve. However, using my protractor, I can see that the angle is 20 degrees. Now that we know the angle is 20 degrees, we can use the equation 2 pi r multiplied by angle 1 over 360 degrees. We know that our angle is 20 degrees, and by adding the length of my arm with the length of my golf club, I can get the radius 1.6 meters. We can plug in our information into our equation to see the change in distance is 0.558 meters. Now we're going to look at our two time intervals, which is 5.63 seconds and 5.7 seconds, and the difference being 0.14 seconds. The video slowed down to an eighth of a speed, so we have to divide 0.14 by 8 to get our change time of 0.0175 seconds. Plug our information to our original equation, and we get our velocity of 31.9 meters per second. Next, I will be calculating the speed of the ball after impact. Initially, I tried to use conservation of momentum, but this did not work because the ball is compressed during impact. I will use the inelastic collision formula instead, which is shown here. If you remember, the velocity of the driver is 31.9 meters per second. E is the coefficient of restitution, which accounts for the kinetic energy used in the compressed ball. E is typically 0.83 during a golf ball hit. And we know that the mass of the ball is 0.046 and the mass of the club is 0.2 kilograms. Now we can solve for our equation. See, the velocity of the ball is 47.5 meters per second. Finally, I can find how far the ball will travel. First, I need to find the vertical component and use this equation. By using this close-up frame, I can use my protractor and find the angle of the club and ball, which is 15 degrees. Now I can plug it into my equation and the ball velocity to see the vertical component is 12.3 meters per second. Now I can take all my information plus the acceleration of gravity and plug it into this equation to get my peak time of 1.26, which must be double to get my total ball air time of 2.52 seconds. Next, I will find the horizontal component by just plugging in the same information into this equation to get 45.9 meters per second. I will then multiply my time and my horizontal component to get a distance of 115.7 meters.